Hey, hi everyone, very good morning. So today we are going to start with performance tuning. So as you people might be knowing, performance tuning is one of the critical areas for Oracle DBA. So the main thing that falls under performance tuning is its practicality. Other topics, whatever we have discussed till now, or we are going to discuss in future, the advanced topics. So we'll be able to see everything what we do in real time as it is. But when it comes to performance tuning, always it will be a no man job. So it's like even though we try different scenarios in our practice, but still when the actual problem comes, then altogether it could be a different one. And we always need to know how to react to that particular performance issue. So, or in what way we need to start troubleshooting that particular issue. So that is the reason even a very well experienced DBA also will not be able to tell what is the exact reason behind the performance issue. So straight away by looking at the issue, no DBA will be able to tell because of this reason we are getting this issue. So coming to performance tuning, so it can be categorized into two sections. One is a proactive tuning methodology and the second one is reactive tuning. So proactive tuning, as the name itself is telling you, you need to do this when any new database is being created. So as it's mentioned in the next few points, it's very important that when you are creating a new database, you should have everything in place. Like you need to have the correct SGA and PGA sizes, and you need to have the OFA kind of things implemented. So OFA basically says we need to place the database files in separate hard disk so as to improve the performance, and how efficiently we are choosing our backup strategy. So that is also important because as we discussed yesterday, if the database size is more, then we need to choose and with the incremental backup. And again, in incremental backup, as we discussed yesterday, we need to see whether we need to go for cumulative or we need to go for differential. And first of all, of course, hardware, because on top of that only everything will be decided. So we need to have a proper hardware, and on top of that the correct OS version should be chosen, and again on top of that we need to have a proper database version. So all these compatibilities need to be chosen, and then only the software installation and the database creation should be done. So most of the times this selecting of the new hardware or OS version etc. will be taken care by the uh, highly experienced DBAs who are in the role of database architect or technical architects. So maybe after you achieve a 20 years experience or 15 plus years experience, you can become a database architect. But it is generally in the very big companies. So sometimes the same chance you might get as a 3 years experience DBA or 5 years experience DBA if you are working for a smaller or medium companies, because small or medium companies may not go and afford a highly experienced DBA to get this task done. So that's the reason they may ask a low experienced DBA itself to give this information. Which hardware is better, which operating system is better, etc. So hardware is produced by different vendors like IBM, HP, Dell and all. So it is also important for a DBA to keep on update on the market, like what kind of servers are getting released into the market, and everything, not only with respect hardware in the sense, not only with respect to the server, but in terms of network switches, or in terms of fiber optic cable changes, what it's coming. So if you have that information handy with you, then it would be good. It is not mandatory, but it is out of interest that you need to have that. And also the details with respect to latest OS versions that are releasing. So like in Solaris, what is the latest version? In Red Hat Linux, what is the late sorry, what is the latest version? And in Linux, what is the latest version? So for my server, which one is suitable? So all this you need to go with. So for example, to give you a thing, if you are planning to purchase a server from IBM, so obviously IBM is having its own operating system called AAX. So it will choose some servers, it will choose to design in such a way that that server hardware is more compatible with IBM AX only. So if you purchase any such server and you try to install Oracle Linux or Red Hat Linux on top of that, then you may see a different performance over that, because that hardware is prepared for IBM AX, but you are using a different operating system. So obviously it will be a altogether different experience that we get. So that's the reason while purchasing you need to make sure all these points. Or for example, if you go with HP, they are also having their own operating system, HP UX. So they might create some servers incompatible with that operating system. But if you go with the Dell, so they just manufacture the server, they don't have any operating system on their own. So they are going to the servers what they are going to create is like a universal one. So it will accept any flavor of operating system. So that's how the things should be chosen. And as I said, operating system version, and then of course the database version. So these are very much important as a DBA whenever you are building a new server or new database. And the most important point here is the thorough testing in the test environment. So as I said, there will be different environments like development, testing, quality and all. So in the test environment, we need to thoroughly test every possible scenario. So that is where test engineers what you say expertise is required, and they need to keep on loading the data, and we need to see how the performance is going on. So even test engineers are having a specific area called database testing, so in which they will test different factors with respect to database. So that need to be thoroughly done on the test environments, so that we can record any ups and downs, and further we can able to rectify that when we are building a new production database. Especially that comes with the memory sizes like SJ and PJ values. So because those are the ones maximum things will be decided. So what would be the ideal SJ and PJ value for the production environment can be chosen from the results of the test database. So that's how the proactive tuning things should work. If you are lucky enough to work on a new project where you are building new databases, then all these things will come into picture. But let's say you are into a supported database service. So in that case, you will be only supporting the already created databases. So there you may not get chance to create a new database in this kind of a project, but still you will be getting a performance issues, which we generally categorize as reactive performance tuning. So in reactive performance tuning, as the name says, once the problem is there in the database, then we will start looking at it. And what are all the things that we need to look at and what kind of issues that we face are the ones which we are going to discuss now. So, and whenever somebody complains about performance issue, so we should not we should not only look at the layer of the database, but there will be other layers like application code, network, operating system behavior, etc., etc. So we need to concentrate even on them. So whenever performance issue arises, so the most of the times the ball game will start. So every team to safeguard their you know to safeguard their to safeguard their team's showness or whatever. So they will say there is no issue from their side. Suppose you ask a network administrator, they say network is very fine. So you ask somebody from application team, they says everything is fine from application side. You ask the Linux administrator, they will say operating system is working fine. So if everybody says fine, but still performance issue is there, means somewhere something went wrong. So that we need to make a note of that. And most of the times, as per my experience and as per the generalization that we have seen, any change that you do in the environment, that will lead generally to the performance issues. And any change in the sense, it could be a hardware change. Let's say you are adding something extra in the hardware, or it could be a operating system level change, like applying a patch to the operating system, or anything with respect to the network, like you are upgrading to a new network firewall, or any change that you in the application code from the application team, or in the database you have done something, some change, like you applied a patch to the database or you did something in the database. So like this, any small change that you do to the environment in the sense, all this hardware, software, everything will come into picture. So if you do that, it is supposed that or 90% of the cases, it would be the reason for the performance issues. Like to take a main example out of all this, application code. So application team will be, updating their codes now and then because of the business requirement. So when they do that, if the things are not thoroughly tested in the lower environment and straight away it was implemented on a production database, so altogether it may give a different thing. So let's say, to give an example, application team is adding some new feature for their application, and they have, let's say, in the test database, they have tested it only with 1 lakh rows on particular table, and it went fine. The test results are successful. But when that same application code moves to the production environment, and let's say in the production table, that table data is having 10 crore rows, then the behavior might be different, because testing on a 1 lakh rows and testing on 10 crore rows will altogether be different. So that's the reason, as we discussed in data pump, always the application team requires the refreshed data from production to the lower environments, because to test these kind of things. So that's very important. Sometimes, I mean, it's not a blame that we can put on, but due to the timelines or deadlines what they have, so many a times the thorough testing may not be performed, and it could be directly implemented on the production environment. So that is what even sometimes I have observed it. So that's the reason whenever a change is happening in the production, we need to have a thorough test results. Application team need to capture that information and they need to present it. So it's not only the application team, but every team. So as a DBA, you are doing some change to the database. You are applying a patch. So first you should check in your test database how that patch is behaving, whether that patch is causing any issue to the application functionality, and you should capture the results. Capture the results in the sense, before applying the patch, what is the performance that is happening, and after applying the patch, what is the performance of DB. So you should capture that information as a proof that in production environment it will be expected behavior. So now coming to this reactive tuning. So in general, we can categorize these performance issues into three types. One is a particular select statement or particular SQL statement is running slow. So then how you will be resolving it. And the second category, a job is running slow. So what could be a job? What is there inside the job and all? We'll discuss it. Or the third category, the entire database is slow. So for each of these things, the approach will be different. So that is what we are going to discuss in our class. So for each of this category, what should be the approach in order to resolve the issue? Where and all we need to check. So or how we need to start and how we need to end. So any questions before we start with the first one? Okay, so starting with the first one, tuning a particular SQL statement. So this is very common that you will be getting. So somebody from the application team, they says that is a select statement. I'm taking select because that is the one which will mostly impact. So there is a select statement which used to retrieve data in 5 minutes till yesterday, and today it is taking 30 minutes. So what could be the reason in order to resolve it, or what could be the reason and what are all the steps that we will take care in order to resolve it. So definitely something is wrong. That's why, instead of 5 minutes, today it is taking 30 minutes. So we need to analyze it. So what we are going to do as a DBA. So the very first step, we need to ask the application team for the tables that are involved in the query, because sometimes the query may have multiple tables which are joined together. So that's the reason, instead of we searching for the tables, so it is a responsibility of the application team to provide the table list, what are all the tables that are involved, and we are going to check something called the latest statistics collected on the table. Sorry. So what is mean by statistics? So statistics are the information what we have with respect to the table, like how many rows are there in the table, what is the row length of the table, and etc. All other information. So Oracle will always have the statistics information handy, because based on the statistics information only, optimizer is going to generate the execution plan. So we already know this point, that optimizer will generate the best plan based on the, time and cost. So we discussed this during select statement processing. So how optimizer is going to generate the plan? It is with the help of these statistics. Now, if these statistics are not up to date, then automatically optimizer will, so optimizer doesn't know. So optimizer blindly will go ahead and it will generate the plan, but whatever the plan optimizer will generate will be the worst plan instead of best plan. So that's the reason always we need to make sure that the statistics information of the tables is up to date. So how we will be able to check that? So we have a query for that, wherein we can able to check what is the latest statistics of the table. So let us go ahead and see that. So I'm just so there is a column called last analyzed in a view called DBA tables. So there we need to check what is the latest statistics that we have. Okay, so these are all the tables that we have, and this is the last analyzed date. So if you see here, the last analyzed date for all the tables is either 21st September or 22nd September, which means it's almost, I can say, 15 to 17 days back. So if a situation is there like this, and I am trying to join some of these tables and execute a select query, obviously the statistics are not latest, so then obviously it is going to create a worst plan and it might affect the performance of the query. So as a DBA, this is the first thing that you need to check. Ask the application team for the tables that are involved in the query and check the statistics on these particular tables. Suppose if the statistics are not up to date, then we have a command in order to gather the latest statistics. So there are different ways to do that. For example, we have an option to go for full statistics. So that is with the help of the command what I am showing right now, or I have highlighted. And apart from that, normally this statistics gathering will take some time. If the table size is huge, even the time taking to gather the statistics will be more, because this Oracle is going to scan each and every row to gather the information. And if your table is having obviously billions of records or billions of records, then you can understand it would take very much time. So again, to avoid that thing, Oracle has another option, especially for bigger tables. You can use something called estimated statistics. So when you go with this estimated statistics, you are not going to collect statistics for entire table because the table size is very big. Instead, you are going to collect the statistics on some percentage. So here in this example, if you see, we may just mention something called 40, which means we are going to collect the statistics of 40% of the rows in the table. So if the table contains some 400 crores rows, then we are going to collect statistics on 40 crore rows. 10% of that. So like that we are going to go ahead with that. And not only collecting the statistics of the table, it is important to collect the statistics of indexes with which are there on the table as well. So that is also important. So if you want to specifically gather the statistics on the index, usually when you collect the statistics on the table, automatically index also will be latest. It will also have the latest information, but still you want to collect it in an individual manner, then you need to go for this. And also when you observe that almost all the tables in the schema are not having the latest statistics, instead of executing the command one by one for each and every table, you can go and analyze entire schema in a single shot. So that is possible with this command. So for example, here you can see almost all the tables are out of date. So here I can execute this command, so that it is going to collect the statistics for all the tables. So it's done. Now let us run the same query. And now you can see it is showing the latest timestamp. So this is how we are going to do that. So that's the first step what we have as a DBA whenever we see some performance issue. So we have even the commands to gather the full database statistics uh, except the base tables, and we have a separate command to collect the statistics on base tables as well. So normally there will be, since 10G, like from Oracle 10G version, Oracle will be having an internal automatic job which will be collecting the statistics of the tables, but it is going to collect the statistics on the tables which are modified greater than 10%. So since yesterday to today, if the table, if the number of rows inside the table are modified by greater than 10%, then only that automated job will collect the statistics, or otherwise it will skip that. But sometimes this might create a problem. So it may not give the accurate results for you. So that is the reason many Oracle DBAs recommend to disable that particular automated job. And instead of that, they recommend to go ahead and schedule some manual job for that. So either through shell scripting or through any other way, you can go ahead and you can schedule that particular job. Now the question here is, okay, if I am doing it manually, how I need to go with, like whether I should collect the statistics for entire database or entire schema, or how I should go. So again, it depends on the database size or the number of tables that you have. Suppose if your database size is very small, like 5 GB, 10 GB, or below 50 GB, then you can go ahead and collect the statistics for entire database, and you can schedule a job every day at night that it need to run the statistics for entire database. But if the table size is keep on increasing, then we cannot have full statistics being executed, because as I said, that will take more time. So in such case, we are going to divide the tables into different categories. So the first one being the static tables. So if you have any tables in which the data will not change once in a month, more than once in a month, so such kind of tables can be categorized as the static tables. And if you have any tables which are not having which are not being changed more than twice in 2 weeks or thrice in 2 weeks, then such kind of tables you can consider as semi-dynamic tables. And if the data is changing repeatedly every day, so such kind of tables can be categorized as dynamic tables. So this again, this list you can get it from application team, because they are the right people who knows which table will be modified daily, which table will not be modified daily, all those things. So that's the reason we need to ask the application team to divide the tables according to this category. And once they provide you that information, then you need to create 3 separate jobs. So one job is to collect statistics on the static tables. That will go as a monthly job, like once in a month if you execute it, that will be fine. Second one will be a weekly job, wherein it will be applied on a semi-dynamic tables. And the third job will be a daily analyze job, where it is going to collect the statistics for the dynamic tables. So that is how the job need to be scheduled. So most of the times it will be done through a shell scripting. So we can get lot many shell scripts from Google itself. So whatever the shell script we got it, we just need to modify a few things and we need to apply it. Or in many of the environments, if you are going with the production support, so already the scripts will be in place. So even if you want to build for a new database, you just need to copy the script from one server to another server and start using it. So if you have an knowledge of shell scripting, of course, that will be an added advantage here. So anyone having any questions? Okay, so going to the next thing, how this statistics of the tables are important. In the same way, the optimizer algorithm what we are choosing is also important. So earlier, optimizer used to work in 2 algorithms. One is called as rule-based optimizer algorithm, and the second one is cost-based optimizer algorithm. But from 10G onwards, because there are so many problems with rule-based optimization, Oracle has removed that as the default one, and it has made the cost-based optimization as the default one. So now you cannot use rule-based even in 11G and 12C. Now, because of this optimizer mode, also the whatever the execution plans or whatever the query scenarios will change. So there are 2 default values that we can put in for this optimization algorithm. So we have a parameter by the name optimizer underscore mode, which will accept 2 values. So the first one is all underscore rows. So that is a default value. So here you can see that. So the default value is all underscore rows. So what is the meaning of this all underscore rows? It means that if a select statement is the database and that select statement requires 10,000 rows, then Oracle is saying to optimizer to give all the 10,000 rows. That is the meaning of this all underscore rows. So that is the generic behavior. So how many rows you ask, Oracle will give those many rows. Obviously that is a general behavior. Apart from that, we have another value also, that is first underscore rows or first underscore rows underscore n, where n is some numerical value like 1 to infinity. and this particular optimizer mode need to be enabled when your application is having data that is being displayed in pages or in different screens. So to give an example here, so if you search something in Google, it will give you the information, it will give you the links, and at last it will give you this numberings, like page number 2, then 3, 4, etc. So if you go to top, you can see it's saying that we got something like 21 crores 70 lakhs results. But is it displaying all those 21 crores 70 lakh results? No. So out of those 2170 lakh results, it is displaying only the first top 10 rows for you. So if you just look at here, so you will get only 10 links here. So when you click on the second one, then the next 10 will be processed, and then those things will be displayed for you on the screen from Google. Similarly, when you click on page number 3, then again the next set of 10 will be processed and it will be displayed on the screen. So this kind of things you might be seeing everywhere, like even in Amazon, Flipkart. So they will not display, if you are searching for a particular thing, they will not give you right away all the information. Instead, they will display you the things in pages. So I'm just taking an example here. So let's say specifically I'm searching here. So here it will not display you all the items on the screen. So the moment you drag down, you can see here there is a paging concept. So it is starting from page number 1 till page number 400 approximately it is showing. So maybe it is displaying 25 results per page or something, and when you click on next, then it will process the next set of 25 and it will display you on the screen. So this this is what we call it as application displaying the data in pages. So if you have any such application, then you should go for this optimizer mode, first underscore rows underscore n. So as I said, n is a numerical value. So if you are displaying 25 results per page, then here you need to say first underscore rows underscore 25. So every time 25 rows will be processed and it will give you the results. So what is the advantage you are getting out of this? Suppose the total number of rows are 10,000, but you are displaying only the first 25. It means that you don't require to process rest of 9,975 rows until unless user asks for that information. And you might be understanding now, like how many times we will click on this second page in Google, or how many times we click on the second page or next page in Amazon or any other website. So it's a very rare case that we go with the second or third or fourth n numbers. So always we try to finish the job within the first page itself. So by which you are saving the processing of the data. So that will again, because you are not processing all the data automatically, that will reduce the load on the database. Thereby the performance will be improved. So that is the concept of this optimizer mode. So now let's say we have collected the statistics, latest statistics. Then we have chosen the right optimizer mode. everything was done, but still the query is running slow. Then what we need to do? Then we need to go ahead and generate something called explain plan. So explain plan or execution plan, it is same thing what optimizer is following. So with this explain plan, you would be able to see what or how exactly Oracle is performing the things. So let me take an example here. So the requirement to generate an explain plan is, first of all, you need to have something called plan table in the sys schema. So you can just say describe plan underscore table. As a sys user, it should show you that it is there. So once you have this plan table in place and you are getting issue with a particular query from a particular user, so to that user you need to first give select and insert permissions on this plan table. So here in the example it was showing as caught, but for example here we have something called TM prod user, so I will make use of that. So first we need to grant these permissions, then we need to connect as that user. Then you need to execute a command. Suppose this is the command which is giving problem for me. Select star from T1 is the SQL statement which is causing issue. So then we need to go ahead and generate explain plan for this, like in this way. So simply you need to say generate explain plan for this statement. So that statement may be a single line statement or it could be a 10-line statement. So whatever the query that you got from the application team, you need to give the same query over here. So what this command will do, it is going to collect the information and it is going to insert that into this plan table. Then from that plan table, you can use any of these ways. Either you can execute a script called utlxpls.sql or you can use a select statement as well in order to see the explain plan of that particular query. So for example, so this is the explain plan what we have for this particular select statement. Now always explain plan should be read from bottom to top. So here, because this is just a simple statement, you are not getting many things out of here. But usually if you get a bigger explain plan, always you need to read from bottom to top. So to give an example, I mean to just analyze this, first it is saying that it is performing table access full, means it is selecting the data from entire database, and for that it is scanning full table. So each and every row is being retrieved. And on which table that you are doing this? On a table called T1. And how many rows totally Oracle is processing? 581,000 rows. And then totally it is going with 73 million 73 MB data, and the cost of the CPU is nothing but the time, the time that Oracle is spending on the CPU is 3120. So time in the sense, again, don't take it as minutes or seconds. So it's like a time factor, but not actual time. What I mean, it's not related to the time what we consider. So this is what for this particular statement. So if we change the statement or if we have a different SQL statement, obviously there will be a different explain plan. So just to take an example, so we'll be getting many explain plans from Google itself. So for example, here it is one of such thing. So if you look at here, as I said, always you need to start reading from bottom to top. So at the last bottom you can see it is some table access fully is happening on a table by the name salary grade, and totally 18 rows is being retrieved, and 960 bytes, and that is the CPU cost, and total expected time is 18 seconds, followed by some hash join filter is applied, and then some partition range single is happening, then table access full on department table, EMP table. So like this the processing need to go till top. So always you need to select the explain plan in such a way. Guys, just a moment, I had a power cut.